All right, the last one, I don't know which order you're watching this in, but I guess this would be a mutually exclusive section right here. So mutually exclusive is basically this joint. That is the definition of mutually exclusive. So non-mutually exclusive would be sets that are joint. They have something in common. So what do you want to watch for here? You want to watch for a problem mentioning a number or percentage of both or neither. Okay? And the scenario would be, I just made one up, 40% of students like applesauce, 50% of students like goldfish, 30% of students like both. So if you have a scenario where they give you, set A, set B, and in this case I gave you both, but it could also be set A, set B, and the one that like neither. In that case, don't use anything else, the dependent events or anything like that. Use Venn diagrams for these ones. What do I have here? Probabilities do not change based on another outcome. That's another one where maybe you might think this is where I need to do a tree diagram, but it doesn't say that, if something happens, 40% like applesauce, 50 goldfish, but if something else happened, let's say it's like a weekend or a Friday, then these numbers change. That is not happening here. Okay, that is not happening here, so you want to kind of keep that in mind. So another thing that gives it away is if you add up the percentages, you're over 100%. Events are joint, i.e. not mutually exclusive. So in this case, we have the A, the applesauce, G for goldfish, and we have the both, we have the middle. We don't need to use pi for this. I quickly figure out that this is 10 because these two combined are 40. I figure out that this is 20 because these two combined give me 50. Then since it's percentages, I know that it's 100% is the universal set. I subtract these three from 100 to get my 40. So now I have a Venn diagram that allows me to answer just about any question, any of the questions. So if it asks like, what percentage of students do not like either one, 40%, which ones only like goldfish, 20, only like applesauce, 10, and so forth, right? Another one that you need to be aware of, you need to be comfortable with a Venn diagram. Let's say this is 50, and I'm just making this up here, okay, as I go on the fly. Let's just put numbers in here, 30, 10, and 40, let's say. So that would mean this is 40, this is 50, and so this is 40 and 40, that's 80. Let's make this outliers be 20, which means we have a total of 100. There you go, I just made up a question on the fly. There are no percentages here. I mean, this coincidentally is out of 100. So actually, let's make this 50 for that reason, because I don't want it to be out of 100. So let's do this again. 30 and 40, 30 and 10 is 40, plus 40 is 80, plus 50 is 130. Okay? So if you have a scenario where there are no percentages mentioned, and I ask you what's the probability of someone liking applesauce here, this is actually number of students, right? We would go 40 over 150 like that, and then you figure out your percentage there. So most of the time in probability, you get percentages, but if you don't, they would have to give you the universal anyways for this to work. So most of the time it is percentages, so you know that it's 100%. But I need you to be comfortable with this as well, just in case. Then you have the rolling dice. Rolling dice. I would recommend, especially if there are two involved, to quickly make an outcome table with the sums. And in this case, it's like rolling a sum of 5 or a sum that is greater than 4. my sum of 5 is right there. It's this one right here. And we've got 4 out of 36, right? And then a sum that is greater than 4, that would be this part right here. And I feel like I probably got this wrong. There's 1, 2, 3, 4, 5, 6 events that are not greater than 4. So that means that there are 30, right? 30 out of 36 that are outcomes that are greater than 4. And just so you know, the green one is inside the orange. So technically I want to subtract that, otherwise I'm double counting. So these actually cancel out. So you end up with 30 out of 36 in that particular instance. Basically, always assume that there might be an overlap. Rolling an even sum or a sum greater than 9. Okay, even, I'm going to use a different color here. An even sum would be your 4, your 6, your 8, your 10, your 12. Okay, I have 17 according to this, so this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 out of 36 are even sums. A sum greater than 9, I'm going to use my pencil for here. Greater than 9 is this part right here. So there's 1, 2, 3, 4, 5, 6 outcomes that are greater than 9. So we add them. Then we're going to subtract overlaps. So in the greater than 9, in this, there are 1, 2, 3, 4 outcomes that I've already counted. So that's why I subtract the 4. And when you add and subtract, you get 19 out of 36. And that is your scenario. And these all involve mutually exclusive or mutually non-exclusive. So this would definitely be non-exclusive, right? There is an overlap. If I asked you what's the sum, what's the probability of a sum less than 7 and greater than 7, they would actually be completely separated. There's no overlap. In that case, you wouldn't have to subtract anything. Hope this helped.